All right, hello ATM. This is going to be a video on section 411, the group portion, because there is no class portion. 411 does not have two separate days to it. It's just a single day. And it happens to be a group day. Now, I didn't have the title slide on here because it's an experiment that we may or may not have done in class. If we had time, maybe we would do it. But it has to do with filling up a bottle with water and then letting it drain and timing it. So I ended up just taking the data from the textbook that they got. So it says cover the drain hole, fill the bottle up to a 20 centimeter mark, set the time to 0, uncover the drain hole and take the cap off the bottle. As the water drains out, record the time for each height in the table. So I just stole the data from the textbook so that we can actually do the math that's related to the experiment. So if I were you, I would pause the video, copy the table down. It can be written as one consecutive table. It just was cut into two different tables so that it would fit on the particular PowerPoint slide. So we're going to use this data. I'm going to move on to number 2. It says use your data to create a scatter plot on the grid provided. I knew this was going to be time consuming, so I went ahead and I plotted the points for us. And you can see that it makes sort of a curve. It's not necessarily a line, but it's definitely a curve if you were to follow your finger, okay? So that's the graph. So I would pause the video once again to do a graph for the notes. Okay, moving on to number 3. Number 3, it says, do you think a linear or quadratic model is best suited to fit the data from this experiment? I would definitely say not linear because from the graph that I just showed you, it definitely does not make a line. It's definitely more curvature. And if you wanted, you could kind of visualize the parabola shape, okay? So quadratic is definitely more appropriate versus linear. So I would write quadratic. Okay? Now number 4 says, what information in the table or graph supports your choice to question 3? And this is a very simple answer. I already verbally explained it, but the graph has a curve to it. It's not a straight line. It has a curve, so quadratic would be more appropriate. Number 5 says, now try your best to ignore the scatter plot and data. Was there anything about what physically happened during the experiment that you think supports your choice in question 3? Now, we were not able to actually perform this experiment, so I went ahead and gave you the answer. But if you were to do this experiment, fill a bottle and then let it drain out the bottom, the water drains very quickly at first, and then when it gets down to the bottom, it slows down more and more as the water level drops. So that's what we would have experienced if we had done the experiment in class, okay? The water comes out a lot faster in the beginning when all the water's in the bottle. Now it says find either the line or parabola of best fit depending on which you chose in question 3. You might encounter coefficients in scientific notation, so watch out for that. Round to 4 decimal places. Find the correlation coefficient if you chose a linear model, and find the value of r squared if you chose a quadratic model. We chose quadratic, right? We definitely said it was not linear. So our calculator is going to provide us with an r squared, okay? So what I'd like you guys to do is grab your calculator. I'm gonna bring the table back into the video here. I want you to press your stat button, go to edit, and we're going to enter the data from number 1 into the calculator. So I would pause the video so that you can put all the data in there. The x values are going to be our L1, the y values will be our L2. Okay? All right, once you have the data in there, we've done this before, but we did it for linear functions. It's the same steps, so you're going to press stat again, stat, arrow over to calculate. And instead of choosing number 4, which was linear regression, we're going to choose number 5, which is quadratic regression. Press enter. If you have a newer calculator, just make sure these say L1 and L2. If they don't, you can change them by using second and then 1 or second and 2 to change it to L1 or L2. go down to calculate, press enter, and it gives us a quadratic equation. So I'm going to write y equals, and then my a value, it did say to round to 4 decimal places. So my a value would be 0.0016, and then the x squared, then the b value, so minus 0.3420, and then the x, and then plus the c value, plus 19.6108. Okay? Now you'll notice my calculator gave me an r squared at the bottom. I'm going to write that down as well. My r squared equals 0.9843 if I'm rounding to 4 decimal places. Okay? All right, so that is my quadratic equation for the experiment that we would have done in class. Okay? Now it says use your model to predict the time when the water in the bottle reaches 2 centimeters above the drain hole. Well, keep in mind that looking at the data, x is time and y is height. X is time and y is height. So they want to find out when will the water reach, so we don't know what x is. When the water in the bottle reaches 2 centimeters, this is your height. And so that means we know y equals 2. So we're looking for the x when we're being told that y equals 2. Well, I put y on my left-hand side. Down here I wrote it as a function using function notation. So what we're going to do is we're going to change the y into a 2, and now we have to solve this equation. Okay? It's not easy. It's going to take a lot of time. We're going to use the quadratic formula. Now, in order to use the quadratic formula, this number must be 0. You cannot use the quadratic formula unless that number is 0. So we're going to subtract the 2 over so that we can cancel those out. Sorry, I probably should erase my line because it looks like division. We are subtracting the 2 away. Okay, so now we have 0 equals, rewrite all my decimals, and then 19 minus 2 is 17. Okay, now I can use the quadratic formula. Remember, the first thing that I do for quadratic formula is b squared minus 4ac. So this is my b value, squared minus 4 times my a times my c. Type that in the calculator. Now, I don't want to round this too much. If I round it too much, I might affect my final answer. And because there's not too many numbers, I might as well just write them all down. So that's what goes under the square root. So now I have x equals negative b, which makes this positive, plus or minus the square root of the number we just found, all over 2 times my a value. Okay? And now we type both answers into the calculator, okay? What I'm going to do is do the plus version first, but remember to use parentheses. We're going to use parentheses around the top and an extra set of parentheses around the bottom, okay? So I'll start by opening parentheses. We've got 0.3420 plus the square root 425,488. Get out of the square root, close the parenthesis, divided by 2 times 0.0016, close the parenthesis. All right, so one of my answers is 127 point, let's see, what do I want to round to? We'll just do to the nearest tenth, so 0.3. And then we want to go back and change the plus to a minus. And we get 86.5. Okay. Now, we want to decide which of these I want to keep. Okay. Remember, we were finding the x value when the y value is 2. So let's look at our table. Here's where the y value is 2. So we expect it to be around 102. okay? And if we look at our choices here, okay, this number is way too big, okay? We started, the end of our experiment ended at 123 seconds, so it wouldn't make sense for it to be past that. So this number doesn't make sense, okay? And this is more appropriate, okay? Let me just add some units. We do have seconds here as our units, okay? It says, how does this compare to your experimental data? We had x equals 102, okay? 102 seconds was our data. Our prediction from using the equation is much lower, meaning the water drained a lot faster if we were using the model, okay? All right, moving on. Now, number 8 says, what is the value of y when x is 50? This is a lot easier to calculate, which is a really nice thing. So I'm going to rewrite the equation that I was given here. So we have y equals 0.0016 x squared 3420x plus 19.6108. Okay. So what is the value of y when x is 50? So this is a lot easier. We just plug 50 in for x. Lots of writing here. And now I plug it in the calculator. Okay, and we get let's see, what do I want to round to? Let's just do the nearest tenth again, 6.5. And that happens to be centimeters because remember, y is height, not time. All right, so that's number 8, finding the value of y when x equals 50. Okay. Explain the meaning of these values, I'll just say verbally. If x is 50, remember x is time, okay? And so the model predicts that after 50 seconds, the height of the water will be at 6.5 centimeters. At 50 seconds, the height of the water will be at 6.5 centimeters, okay? All right, now they give us another really tough question, and I decided to work it out ahead of time because it's almost the same as number 7. Look at the work for number 7 compared to number 9. I just didn't feel like it was necessary for me to take video time to do that whole process twice, but feel free to do it on your own, pause the video and give it a shot. It says find the value of x when y is 11. So we put 11 in for y, we subtract it over, we now have 0, and then we do the quadratic formula all over again. Okay? I just didn't feel like it was worth our time to do that twice during the video, but you should try it at home and make sure you're getting it right. Okay? All right, moving on. Now, number 10 says, in case you're not wet enough already, we're going to repeat the experiment. So they repeat the experiment. It says, this time though, instead of noting the time every 2 centimeters, we're going to note the height every 10 seconds. So it's going to be in terms of every 10 seconds instead of 2 centimeters. They give a little bit more. So here's the data from the textbook once again. Go ahead and copy it down into your notebook. Then what we would do is the same thing as we did for the previous question. Put this into your L1 and L2. So the x values would be your L1 and the y values would be your L2. And then go to stat again, arrow over to calc, and do quadratic regression. This is the equation you should get if you do quadratic regression. And this is the r squared value that they give us. I went ahead and took the liberty of doing that ahead of time because, again, it's the same process that we've already done in the beginning part of the video, okay? But I did want to make sure we discuss these follow-up questions. Number 12 says, compare your 2 models both algebraically and graphically. Discuss similarities and differences. Which is the better fit for the data you found and how do you know? So what I ended up writing was the graphs and equations are similar. They are modeling the same situation, just using different x values in the data. The new one from number 11 is slightly better because the r squared is slightly closer to 1. Now, I would argue that they're both pretty good. For number 6, our r value was 0.9843, and then the r value for number 11 was 0.9892. Those are both extremely close to 1, so I would argue that they're both pretty good models for the data that we were given. But yes, the new one is slightly better because it's a little bit closer to 1. Why do you think the bottle didn't drain at a constant rate? Think about what's happening physically. If you think about it, when you've got a full bottle full of water, it's very heavy. So the water is heavier at the start when there's more of it. So gravity has a larger effect and the water drains faster. As the water leaves the water bottle, it gets lighter and therefore it's not going to drain as quickly because it's not as heavy. So hopefully that makes sense. Moving on to the last portion. It says, in the table, use your equation of best fit to find the residual. Now, we have found residuals in the past. This was when we were actually in school together. What I ended up doing was I copied the second table that we were given. So I copied from question 10. So this table here from number 10, this is technically one big table. They just split it up into 3 so they could fit it horizontally. So I took those numbers from number 10 and I put it into the Y column here, okay? Then what I want to do is show you how I got the next column. So what I want you guys to do is to type this equation into your Y equals from number 11. I already have mine in there, okay, from number 11. And then I want you to go to the table, okay? I ended up changing my x values to go by tens because my x values here go by tens. If you don't know how to do that, it's just above your window key. Above your window, you can press table set, so second window, and you can tell it to start at 0 and then go by tens. And then you can go to the table and you can write down the corresponding y values from the equation for whichever x value you're looking for. So for the first one, when x is 0, y is 19.4. So that's where I got the 19.4, okay? Now, you might not remember this from class, but in order to find the residual, you do the actual minus the predicted, and that will get you the residual. So I did the actual, which is 20, minus the predicted from our equation, and I got 0.6. So subtract straight across, and you should get your residual, okay? Now, it says, are there any points for the residual that jump out as being very unusual? None of these are really big or really, really small. So I would say no, there are no numbers that stand out. And that's because the r value, the r squared value that we got from number 11 is so close to 1. If the r squared value was closer to 0, that would mean that it's not very accurate. And so these residual numbers would be really big. But these residual numbers are all really small, fairly close together, and that's because the r squared value is so close to 1. So none of these stand out. Okay? All right, that's the last of it. And you guys, that was the very last lesson in ATM. So you just listened to your last math class lesson. And if we were in class together, we would do some sort of a celebration, I'm sure. But that's it. So you are done with ATM in terms of lessons. So congratulations. I really miss you guys. Thanks for watching. Thanks for listening. And let me know if you guys have any questions. Okay? All right. Goodbye.